Look at me go. All right. So, so right now that's nice. So right now you all can see what I see, right? With using synthetic division to find roots. Note that synthetic division only works for linear factors, but long division will work for all of your polys. And in the problems below, you're given an equation, a polynomial equation, and one or more of the roots, and your job is to find the remaining roots. So one of the things is there's a couple of things that I want to address today, and it's using synthetic division and using synthetic division to do what we need to do. But then your job over the next couple of days is with whomever, and whether it's in this class or period 5, your job is going to be figuring out why synthetic substitution is the same exact thing as doing direct substitution. And when I say direct substitution, like if I were to plug this 3 into the function, it's going to give me 0 because it says it's a root. How come when I go through that process, it's the same thing as doing synthetic division? So that's going to be one of the big things that you guys are going to have to figure out. And you can talk to whomever you'd like to about it, and we'll have a delightful conversation. Okay? Are you knuckleheads ready? Are you ready?
Yeah.
Okay, so just so you know, this is interactive. This isn't just me like having a staring contest with myself, okay? All right, so if we look at the first one, what is the degree of this poly?
3.
It's a 3rd degree. And if this says it's a root, that means I already know that I can write this as a factor. So what would the factor be for x minus 3? I just gave it to you. I just gave it away. It's a root. Oh my God, I just gave you the answer. So yeah, if the root is 3, then I know that the factor is going to be x minus 3. Is everybody okay with that?
Yes.
Yeah.
Okay, so that would be my linear factor. So now we put the little 3 in its little box over here, and we put our 2, our -5, our -4, and our 3. Is anybody writing this down along with me?
Yeah.
If you are, you can. You don't have to. If some of you enjoy watching, I know Gavin is somebody who likes to just look at stuff and then do his thing. I know Gavin does, but I also know that Lena has to write everything down, as does Hillary. So, there's some of us who have to write everything. Akul is probably just watching and like chewing on like the string. So, All right, so we bring down the 2, right? We have this times that is 6. So this gives us uno. This is a 3, right? This gives us -1 and then -3. And of course, our remainder has to be 0. Why?
Root.
Why does it have to be 0? How come I know going into this my remainder will be 0?
There's no double root.
It's not because there's no double root. How come I know that?
Root because x minus 3 is a root or factor.
Right. If this says a root is 3, another way of saying it is that another way of saying root is saying it's n
0.
What?
A 0? I don't think that's
It's a 0. Yes, it is a 0. You can also call it a x-intercept. Yes.
Yes.
Right. When it's a root, we can also, if we knew that going in. So if I say something's a root, you already know that your remainder has to come out to equal 0 because it's telling us that it's a root, it's a 0, it's an x-intercept. So now, what is the significance of these numbers here? What are these guys?
Coefficients
Coefficients of what, Kai?
of the root, the x squared, x cubed, x
So wait a minute. Is the 2, it's a 2 what? 2x,
squared,
okay, followed by?
x.
And then -1. Good. So yeah, when we take a cubic function and we divide it by it's like you're dividing it by this linear factor here, right? That means that whatever you're going to be left over with is going to be a 2nd degree polynomial, right? Because remember, the goal is to find out your remaining roots. So you want to find out what the remaining roots are. We already knew 3 was a root. We're like, of course, because the remainder is 0. What should we try to do here?
Factor.
Yeah, good. And what happens if you can't factor? But we're going to try to see if we can. But what if you can't? What would we do?
Quadratic formula.
You got it. Who was that?
What?
Who was that?
Quadratic formula?
Who was it?
Wait, who said quadratic formula?
Yes.
Me.
Who's me?
Lena. Kim.
Okay. I can't see your faces, so you guys can all, because I'm my screen, that's why I can't see you. All right. Okay, yeah, so we would use the quadratic formula. But let's see if this is factorable. Go away. All right, so is it factorable, gang? Can we factor this? Because first of all, if it's 2x squared, I know that this is a 2x and an x, right? Now, if I throw the 1 in, can we throw the 1 in a place that's going to work in our favor, yay or nay?
Yes.
Yay, right? Absolutely. So this is going to be, I can make this +1, I can make this -1, because if you look at this, I said 2x minus 1x is a positive x. So if I ask you for the other roots to this cubic function, what are the other two roots?
-1.
-1/2.
-1 and
1/2.
1/2. Thank you, Katie. That was Katie, right?
Yeah.
Yeah, okay. She's like, I'm gonna be all quiet. So over here, so a couple of things that I want to note, okay? There's a couple of things here that I want to note. When we first divided the x minus 3 factor, you can write this original cubic function as f of x is equal to x minus 3 times 2x squared plus x minus 1. Would you all agree with that?
Yeah.
Yes, because if I were to multiply this out, right, because when I divided this synthetically, I got these as my coefficients to my quadratic that Kai said that we had. Is everybody in agreement?
Yes.
So
Yeah.
if I FOIL this out, I should wind up exactly where I started. Yay or nay?
Yay.
Right.
Yeah.
And then the thing is I can actually write this function as a product of linear factors. Does that make sense? I can write that function as a product of linear factors. And if I do, it's going to be x minus 3 times
2x
X minus 1.
minus 1.
2x
2x
minus 1 times
x plus 1.
plus 1. So I just want to say, is it fair to say that this function right here, is everybody looking, that the original function here, this function right here, and then this guy right over here are all the same exact function?
Yes.
Yes, they are. This one just outlines who the exact zeros are. So if we wanted to go and graph it, we could easily plot 3, 1/2, and -1, and then do what we needed to do. If you're okay with that. What, huh?
For like the second one in the middle, can you do like x minus 1/2? Like, is that the same thing?
Yeah, well, if you did this guy here, then you would have it where it's 2 times x minus 3 times x minus 1/2 times x minus 1. But you have to remember that coefficient, if you're pulling that coefficient out, you got to put him out front. So, all right, so here we go. There's 4 of them. So you have this function, this function, this function, and that function are all saying the same thing. Are we all right with that?
Yes.
Yay? Good? Yes? All right. And if I were to actually, or if you guys were to actually put all of those into Desmos, true or false, you would have the same function.
True.
True.
Yeah, absolutely. And if you don't believe me, you have the video in front of you. You could go and type it in later on. Okay. Number 2. Any questions on number 1 before I march on to number 2? Okay, I'm assuming that's a no because this is like dead silence. All right. On number 2, what is the degree?
4.
4. I gave you how many roots already?
2.
How many are remaining? There's 2 left, right? We all agree that there's 2 left. So again, if we do synthetic division, the nice thing is, if you want to do 1 or -1 first, it doesn't matter. We'll do 1. Somebody use the thing of 1. Now, by the way, are any of our coefficients missing? I mean, is everything, all of our x terms are going down in descending order, right? So we don't have to account for zeros anywhere?
Yes.
Okay, good. All right. You see how I'm waiting for responses? Yes. Okay. It's almost as if we're in school. Oh, we are in school. So I'm going to go ahead here. I know, right? Now, what should my remainder be, by the way, after I, do all my magic here? What should be in the little box over here?
0.
0, because we said it was a what?
A root or 0.
So now we're going to go down. You guys do it too. See if your numbers work out with mine. Okay, -7, -5, -4, 4, and sure enough, I get 0. Are you all with me?
Yes.
Did you all get my? All right. So now, if I took this quartic and I divided it by this linear factor x minus 1, what is the coefficient? What is the degree of this coefficient?
2x cubed.
2x cubed, exactly, because we're going down by 1 every time. If everybody, are you all with me on that?
Yes.
That's 1 person. There's like 9 people in here. Is everybody with me?
Yeah.
Okay. So now the nice thing is that this is called, do you remember what polynomial I call this? Like when you divide it, what you call it? Starts with a D. Another word for sad.
Depressed.
Yeah, remember how I call this the depressed polynomial? So this would be 2x cubed minus 7x squared minus 5x plus 4. So again, like I said, as we said earlier, I could do your x minus 1, times your, 2x cubed minus 7x squared minus 5x plus 4, right? That's how that would be written now, since I know that this is a root, so I know that x minus 1 is one of my factors, right? So now what we could do is we could take that second root that I gave you, and we can use this set of coefficients now to move on to the next level, because if I do that, if I do -1, I can take those coefficients, the 2, the -7, the -5, and the 4, because if I divide that out, what is going to be the degree of of whatever's left over?
2.
It's going to be a 2. And again, because it's a root, I'm going to guarantee, I'm just going to brazenly put what here?
0.
I'm going to put, you damn right I'm going to put a 0 in there, right? So now let's go ahead, and we're going to put a 2 there. We're going to go through our magical stuff, right? And then this gives me -9, and then that gives me +9, and that gives me a 4, and that gives me -4, and look at me go, okay? Right? So now, because this was your 2x cubed minus your 7x squared minus your 5x plus 4, so now we're left with, talk to me, 2x squared, good, minus 9x minus 4. Well, in this instance, you're going to want to ask yourself, before you do anything, you should always try to see if you can do what first, gang?
Factor.
Start with the factors. So let's see if you guys can see if that's factorable.
So would it be +4?
What'd you say? It would be plus. Oh God, you're here. Yes, it would be +4. Thank you, Aiden. Yes, it would be +4. I don't know why I did that last time too. I'm a hot mess. Is that factorable? Yes, it is. Stop. Just saying. All right, I'm waiting for you guys. I'm going to fill in the blanks here when you guys have it.
X minus 4 to x minus 1.
X minus 4 times 2x minus 1. Do we agree with that factoring?
Yes.
Yeah.
I do. Okay, so what are the other roots to this original function? So we have 1, -1, and then we have x equals?
2x minus 1.
Well, what's the root? I'm asking for the root.
1/2.
Oh,
1/2 and
4.
and 4, right? So, and if I wanted to write this function as a product of its linear factors, I don't know if you guys will see yellow, but I don't care. Yeah, you can. So you can do it as g of x is equal to, you could do x minus 1 times x plus 1. Keep talking to me, times
X minus 4.
x minus 4. Thanks, Kai. Times
X minus 1.
x to x minus 1. Good. Okay. And then Aiden, if you don't like the 2x minus 1 there, you can just pull the 2 out front and make that x minus 1/2 if you want.
Okay.
You all right with that?
Yeah.
Okay. So everybody, what you're going to do is you're going to copy number 3 down, and you're going to start working on that one on your own without yours truly.
But you see, Carl,
Yeah.
if you pulled out the 2x minus 1, then would you have to change everything else as well?
No, it would just be right over here, because if you think about it, where am I? Where's my little pen? All right. So if you're thinking about it, like if you're like, okay, I insist on factoring the 2 out of here, this would be x minus 1/2. Yeah? And this is all a product, so you could just bring the 2 out front, and 2 times x minus 1 times x plus 1/2 times, you know what I mean? It would be the same thing as I said up here, because Aiden was insisting like this factor of 2x minus 1. He's like, I want to write it as x minus 1/2, but he pulled the 2 out front so he could account for that. Because remember, your goal is if I was in a bad mood and said, you have to multiply everything out, whatever you have as far as that product goes should bring you back right here to the original function, or whatever the original function is right there. So no matter what you do, that should always work. Okay? All right. So let's go on to number 3. You knuckleheads, start copying down number 3, because I have to go to a new page, because you can see there's no more room left on this one. All right. So the button is, oh, I have it right here. Look at me go. So let me know when you have it written down. And I'm going to ask you guys to do the synthetic division and bring it down to that depressed polynomial, because if you're taking this, what kind of a function is number 3? 3 is what kind of a function? Anybody shout it out?
Quadratic.
Quadratic, thank you. And if I divide it by -1 and then I divide that by 2, by the time you go through synthetic division 2 times, I should be down to what kind of a function?
Parabola.
Correct. Quadratic.
Yes, quadratic. You can even say parabolic. I'm okay with that. All right. So have you all written that down so I can go on to my new page?
Yes.
Yeah.
All right. Now, and that was, I even have it in front of me. Look at me go. And now I have x to the fourth. By the way, I'm so happy you're all here, by the way, for those of you who showed up today. It means a lot to me. So x to the fourth minus 2x cubed x squared minus 4. Now, do you guys notice on this one, and the roots were -1 and -1, right? Okay. Are we missing anything here in the poly? Are there any terms missing?
Yeah.
Yeah.
What? Which term is missing?
The linear term.
Linear.
Oh, you're missing the linear. So don't forget that you have to account for that when you're doing synthetic. So you should have your 1, your -2, your 1. Don't forget you need that 0 and then that -4. Okay? And then I'll wait for you to go ahead and finish up, and then I will go ahead and fill mine in when it's all said and done. How we doing?
Good.
Does everybody have what I have?
Yeah.
Yeah.
Okay, so the new quadratic that we all wound up with was, you have x squared minus x plus 2 from these coefficients here. Yay or nay, friends?
Yeah.
Yay? Okay. Does this factor?
No.
No. So we have to use
Quadratic formula.
Quadratic formula.
quadratic formula. Okay, so I'll let you guys figure it out. All right. I'm gonna stare in contest with you. Let me go and hide this for a second. And I'm gonna take off for a minute. Stop presenting. And I'm gonna see what let's come up with. We lost some people, huh? A couple of people left us. Is that right?
I believe so.
Yeah, that's okay though. Look at the cool. Only the cool people stayed though. So that makes me happy. Okay. I'm gonna go back to present now. My entire screen to see where you guys are. How is your quadratic formula working out? All right. Well, I'm gonna take mine and this, right? Plus or minus the square root. What kind of numbers did you wind up with?
Lateral and imaginary.
Ah, lateral / imaginary. Very good. As you should have. As you should have. So that's 1 times 2, right? All over your 2 times 1. So we have x is equal to 1 plus or minus the square root. I'm seeing -7 in there. Is that right?
Yeah.
Yeah.
Okay. Which is going to leave me with 1 plus or minus I times the square root of 7 all over 2. Are we all okay with that?
Yes.
All right. Now I'm going to ask something super crazy right now. Say, what is it? If I want to write this as the product of its linear factors, and I go back to that, I think it was h of x, right? It would be equal to, I'm seeing x plus 1, because that was a factor, because -1 was a root, so x plus 1 is a factor, times x minus 2, because 2 was a root, so x minus 2 is a factor. How do I write these two as factors? How would I write like 1 plus or minus, or how about this? If I did 1 plus I root 7 all over 2, and I know the other root is 1 minus I root 7 over 2. How would I write those as factors? Anybody can shout out.
Like x minus 1 plus I root 7 or
Minus, just make sure you use what there, my friend?
Let's see.
parentheses.
Right there, throw parentheses in, and it's going to be 1 plus I root 7 over 2. Okay, that's a 7. And that's 1. And then the other one, you would do x minus, the important thing is that parentheses, right? And then it would be minus I root 7 all over 2, and then close that parentheses out. And I'm going to tell you what, this guy right here, if you multiply this and this together, I'm going to bet the farm that you should wind up back to this, just so you know, okay? And yes, I think you should do that. I think you should go back when you have time today, look at this guy, multiply it by that guy, go through the mathematics, and you should literally wind up with x squared minus x plus 2 to guarantee that you know what you're talking about, okay? So going back,
I have a question.
go ahead, babe.
For the roots, you know how we did -1 first, and then we did the same thing for 2? Like, even if we did that like vice versa, would you still like get the same
Yes.
answers? Okay.
Yes. Oh yeah, yeah. You might have different coefficients, but you'll wind up. How about this? If you did 2 and then -1, you're still going to wind up with that same quadratic. By the way, and you know what? Do it. Actually, do it out when when we're done. Go and do it and be like, oh, it does wind up the same way. But that's a super question. Excellent question. Any other questions? Any other questions? Yay or nay?
Nay.
No.
Okay, so let's go back. So here's one of my questions. So I want to go back to this guy here as one of my things. How come if I wanted to do, I'm going to squeeze it in here because I have no space. If I find f of 3, like for example, if I'm doing 2 times 3 cubed, the marker, this little pet is dying, minus 5 times 3 squared, minus 4 times 3 plus 3, that's a 3. How come that doing that direct substitution is the same thing as doing synthetic substitution? How come this process is the same exact thing as that process? And that's one of the questions I'm asking you on your homework today. So that's that you'll have a couple of days with which to think about it, and I want you to talk to other people in class about, and even from the other class period. Okay?
Mm-hmm.
All right, so I'm going to get off here, stop presenting. I'm going to hit even stop recording. Any other questions? I'm going to stop recording.